Hi guys, thanks for coming to OLED Wave paper reading channel. Today we're going to be reviewing a classical paper that calls the VALL-E 2. Neural codec language models are Human Parity Zero-shot text-to-speech synthesizer. This is a short review. There are two main contributions or two novelties mentioned by the authors. First is called a repetition-aware sampling, and the second thing is called a group code modeling. This repetition-aware sampling is supposed to be more robust than the original nucleus sampling, which is also called a top p-value sampling or something like that, and to account for the token repetition in the decoding history. And the second thing is called a group code modeling, which makes their inference more efficient. And their results on the LibriSpeech and the VCTK demonstrate that their value to surpass the previous system and reach the level of a human being's speech quality according to their subjective evaluation. And you can definitely check their demos or just listen to their demos. But the models are not open source. The model weights are not open source. The training code is not open source. There's no inference code either. This is the introduction, and this is the algorithm part, and this is the general algorithm of it. If you have checked our paper reading of VALL-E, you would see this is very similar to the VALL-E 1 model architecture, except the only thing is that they use the group coding. You can see there's a besides. You can see the code here. The code is you want to convert the prompt speech into codes through codecs, and the codes here, besides the index of time, they're grouping adjacent time indices into a group. So you see this is a C0 to G other than CT, okay? Otherwise, this is the same, and I will first quickly overview the inference section, which they mentioned their novelty things called repetition-aware sampling. The only thing is you want to pay attention to is for in their AR model decoding to generate the first code, okay? You can see this is the code 0, okay? Because they have 8 codes. This is the first code they generate through the AR. And they use a window size of T. So when the nucleus sampling keeps repeating the same, choosing the same samples in the window, then if the repetition ratio is higher than the certain threshold, they would replace the C sub T prime by randomly sampling the probability distribution. I think that the idea is they don't want the repetition pattern appeared in their sampling or in the generated codes, because that would probably stir the repetition generating the same words again pattern which people have seen in the previous TTS generation algorithm. Okay, that's the main idea of it. In the VALL-E 1, I think if something is keeping the same, they probably do some random sampling, but this is the first time they use this repetition-aware sampling to avoid the same patterns appear in the code again and again. Okay, regarding the results, you can see this is something I'm most into. I want to check the speaker similarity, mean opinion score, and the CMOS score. Okay, this is how the quality of the speech. This is whether this is similar to the synthesized speaker. If you ever pay attention to our paper read in the VALL-E 1, you would know all the settings. Okay, and then you can see there. VALL-E 2, they achieved a 4.6, which is really amazing regarding the speaker similarity. And if they use a group size of 2, they accelerated the inference, but you can see the SMOS didn't drop that much, and it's still higher than the VALL-E 1. Okay, and it's very interesting. This is even VALL-E 1 and 2, they are higher than the ground truth in terms of a speaker similarity score. And in terms of the speech quality mean opinion score, VALL-E 2, they do better than the ground truth. Okay. And of course, they have these similarity matrix, word error rate matrix, deep noise suppression mean opinion score, which are all automatic scores. They use this to analyze this. They analyze this on the VCTK and the LibriSpeech. And I also want to mention that one thing which is different in terms of the training data in the VALL-E 2 compared to VALL-E 1 was the use of a LibriHeavy corpus. I think in the in the VALL-E 1, they use something like 60K hours of unlabeled data, but this one is a labeled version of a LibriLite corpus. So they introduced the ASR labels or pseudo labels into the training of their model. It seems that the ASR result provides a good guidance for them, and this is helping as an extra information for them to get better synthesized speech. Okay, just to say, VALL-E 1 doesn't have ASR transcription in their training set. Okay. Okay, I think this is that's it for the short review of the paper.